Assalamualaikum warahmatullahi wabarakatuh. My name is Siti Nur Aziera with Ahmad Kamal Ariffin. Today I would like to present my final year project entitled The Effect of Propylene Carbonate on the Electrical Properties of Jackfruit Seed Starch Polyvinyl Alcohol Polymer Blend Electrolyte with zinc oxide nanoparticles. This research is under the supervision of Madam Fairuza binti Ahmad Lutfi. First of all, in solid-state electrochemistry, one of the most popular research areas is the invention of ion-conducting materials for a wide range of applications, especially for conversion and storage of energy. Solid-state electrolyte is divided into three main categories, which is inorganic solid electrolyte, solid polymer electrolyte, and composite polymer electrolyte. Among the three main categories, solid polymer electrolyte had been chosen as their potential candidate. This is because it has good thermal resistance, no leakage issues, low manufacturing costs, and occupied larger surface areas. However, solid polymer electrolyte exhibit low ionic conductivity at room temperature, approximately 10 to the power of -8. Hence, in order to increase the conductivity value, there are three main alternatives that has been introduced, which is polymer blending, plasticizer addition, and the introduction of nanoparticles. The problem that led to this study is firstly caused by the nature of polymer electrolyte that exists as semi-crystalline, which hinder the ion's movement. As a result, low ionic conductivity. On the other hand, the synthetic polymer electrolyte is non-degradable, which is normally used as polymer host, which later will contribute to the production of electronic waste, e-waste. The significance of this study is related to the National Environment Policy (NESN), which is to reduce e-waste pollution by encouraging recycle through utilizing jackfruit seed, which is fruit waste. Other than that, National Policy of Science and Technology and Innovation had recommended to become innovative research under Research and Development Program. Hence, ionic conductivity polymer electrolyte is to be produced. We proceed to the objective of study. There are two main objectives of this study, which is first to prepare solid polymer electrolyte by using jackfruit seed Starch-PVA polymer blend. Secondly, to investigate the effect of plasticizer addition on the electrical properties of JFS-PVA polymer blend with nanocomposite. We move on to the literature review part. First of all, the effect of different metal oxide on polymer electrolyte. The electrical conductivity of polymer composite is brought by the interaction between electric charge carriers and the polymer itself. Secondly, nanoparticles in nanocomposite polymer electrolyte has complicated nature. This is due to the disorientation of solid-state nanostructure in the polymer matrix that affect the mobility of charge carrier. Next, the advantage of jackfruit seed starch. First of all, jackfruit has reached 3.6 million tons of production with huge application as thickening agent, food stabilizer, and gelling agents. Other than that, it is reported that jackfruit seed starch has highest amylose percentage, which is 38.34%. Amylose content is suitable to produce good mechanical properties polymer electrolyte and high stability. Next, we move on to the role and effect of plasticizer. First, it contains high dielectric constant, which is useful for dissociation of ions into amorphous matrix. Next, conductivity value increases when plasticizer added due to amorphous nature. Lastly, limited conductivity of plasticized polymer had led to the introduction of nanofiller particles. Lastly, this is the reason why we choose zinc oxide as our nanoparticles. It is because it has outstanding structural and electrical behaviors, better chemical stability, size approximately 9 to 250 nanoparticle, more free space created for ionic movement, high electrical conductivity, and prevent recrystallization in the matrix. Lastly, high crystallinity with no indication of. Next, we proceed with materials and methodology in this study. First of all, this is all the materials that involve in producing polymer electrolyte. For sample preparation, we started with a ratio of 50-50 JFS powder and PVA powder, weighed and dissolved in distilled water. Both components undergo double boil method for 40 minutes separately. After that, glycerol, hydrochloric acid, sodium hydroxide is added into JFS mixture in 10 minutes interval. After that, after homogeneous, and then PVA mixture is added into the jackfruit seed mixture. After that, sonicated zinc oxide is added into the mixture. Zinc oxide is sonicated under 60 Celsius for 60 minutes. Lastly, plasticizer of different concentration is added into the mixture. You can see here, different sample composition is put into petri dish and let evaporate in room temperature for 48 hours. From the left-hand side, it shows lowest percentage of plasticizer, and right-hand side show the highest percentage of plasticizer. For sample characterization, we use EIS analyzer. First of all, thread sample is cut into dimension 1 cm x 1 cm, and then sandwiched between two metal plates before clipped to positive and negative electrodes.
The frequency range that is being used when analyzing the sample is between 10 to the power of 3 to 10 to the power of 5 Hz with amplitude 10 mV. We can see increasing peak at the end show the zinc oxide is detected, while the region below is show the RB value, which is used for further testing. Now for result and discussion. First of all, this is the impedance spectroscopy studies. This is a graph of conductivity versus sample. You can see the highest conductivity value is at 7 weight%, which is the blue graph. From 1 weight% to 7 weight%, the conductivity increased because of the introduction of plasticizer improvised the polymeric chain. After 7 weight%, we can see that the conductivity decreased. This is because plasticizer rich phase appeared, hence it is difficult for nanoparticle to penetrate in the polymer matrix. Okay, this is the table of value of conductivity, RB value, and relaxation time. This is graph of Nyquist impedance plot, which obtain the RB value. RB value can be used to calculate the conductivity by using formula L divided by RB times A, which is L the thickness of sample, RB is obtained from graph, and A is the area under observation. Next, we proceed to the dielectric properties of sample. This is a graph of dielectric versus log frequency. As we can see, high sample conductivity exhibit high dielectric properties. This is because high dispersion at low frequency associated with the electrode polarization process. After 7 weight%, the dielectric properties decrease due to the interaction of zinc oxide nanoparticle with PVA matrix. Next is the relaxation study. This is a Debye type graph of loss tangent versus log frequency. We can see high PC concentration exhibit low relaxation peaks, and then peaks shifted to the right of the graph. This is because low time relaxation, faster segmental dynamic in system indicates higher probability of ion hopping. Plasticizer also dissociate ion pairs into free ions and improve the flexibility. Last but not least, the electrical modulus. This is a graph of electric modulus versus log frequency. We can see that dispersion value increases at high frequency. Sharp rise at higher frequency indicates polymer electrolyte exist as ionic conductors. Inclined long tail generated at low frequency indicate the polymer electrolytes withstand the polarization phenomenon. Move on to the conclusion part. You can see the optimum conductivity is achieved at 7% of PC. And then the electric properties also follow the same trend as conductivity, where highest value owned by the highest conducting sample. Next, highest sample conductivity exhibit higher tangent loss with lowest value of relaxation time. Last but not least, bulk resistivity effect caused sharp rise at higher frequency in modular studies, while at low region the polymer electrolyte withstand polarization effect, which depicted through long tail at the end. Future recommendation. In the future, we are planning to prepare a sample and proceed with testing by using other instruments such as FTIR and UV-Vis to study the interaction between molecules. Other than that, we want to propose application of high conductivity polymer electrolyte in electronic device. Hence, more appropriate studies and research have to carry out. This is the project achievement for this research. Okay, and that is all from me. Thank you for watching. Stay safe and stay at home.